Okay, question 13. So, what's the reactions at B and C? We've got a single UDL, kind of a bit of a table thing, just a little bit hanging off. So, what's the reactions? So, how do I solve for UDL? Well, the first thing I want to do to find the UDL is to find out what the total UDL force is going to be. So, total UDL, it's 200 kilonewtons per meter. This is 3 meters long, so it's going to be 200 times 3. So it's going to be a total of 600 kilonewtons. Notice that I've gone from kilonewtons per meter to kilonewtons. So that's what the UDL total force is. Right, so we know that. Now we want to find the midpoint. So one way to do this would be to say where's your start position from taking this to be x to be 0, so you've got 1. Where's your end position? Well, 1, 3, 4. So take those two numbers. So we've got 1 plus 4 is 5. Divide that by 2, gives me 2.5. Now we want to plot where 2.5 is. So we've got 1, and then we've got another 1, so that's 2, and then we've got a half. So 2.5 will be there. So this distance will be 1.5. In case I need it. And this distance will be a half. And the total load is 600 kilonewtons. Right. So let's find the reactions. Where's the logical place to start? I think take moments at B. The distance from here to here is 1.5. The total load of the UDL is 600. So we've got 600 times by 1.5. Distance from B to the next reaction is 2. This is going to have reaction force going upwards. So this is going downwards, that's going upwards, negative. So minus distance from here to here, minus 2 times CY. Minus 2 times RCY. And that's it. We've only effectively got one load. We can concentrate all the load of that UDL to one point and pretend that it's a single point acting at that position. Equals 0, so RCY equals 600 times 1.5 divided by 2. 600 times 1.5 divided by 2 gives me 450 kilonewtons. Now I could just like add up the forces, and 600 take away 450 will give me 150. That would give me the other reaction at B. It makes sense because it should be less. What's a good plan is take moments at your two pivots and then use the summation of your forces as a check that you've got the answer correct. So we'll say, what's the summation of moments at C? We go around clockwise, so nothing's on this side. This side we've got, if I'm taking this to be my pivot point, and it wants to go clockwise, that's going to give me a negative moment, so minus 600. Distance from here to here is a half. Then we've got distance from here to here, and in this case our BY will be going in the right direction, so positive moment, so plus this distance of 2 by equals 0. So we've got 2by equals, so when that goes over to the right hand side it becomes positive. So we've got 600 times 0.5 divided by 2. Let's put that all into my calculator. I can work out in my head. 600 times 0.5 gives me 300 divided by 2 gives me 150. Yeah, so for completeness I could do a check. Let's sum up the forces going upwards. And what do we have? So the first force we got is the RBY, so that would be 150. And the total force we've got going downwards, you could either say it's 600 or you could say it's minus 200 times 3, taking into account that it's a UDL. And then we've got plus 450 equals 0. And we're going back to our original data with the 200 times 3. So 150 minus 200 times 3 plus 450 equals, yes, 0. So check.